This is Dr. Sudha from Government Science College. Today's lab topic is basis and dimension. So let us see what is the definition of a basis. A subset B of a vector space V over a field F is said to be a basis if B is linearly independent and B generates B. If B is a vector space, a basis consisting of finite number of elements, then V is said to be a finite dimensional vector space. Next, let us see the definition of dimension. The number of elements in a basis is called the dimension of the vector space V. Here are some results based on basis and dimension. In an n-dimensional vector space V over a field F, any n plus 1 vectors are linearly dependent and any set containing n minus 1 vectors do not generate V. And if in an n-dimensional vector space, any n linearly independent vectors form a basis of V. So we use these results while solving the problems. So let us see the first problem here. It states that show that the vectors 1, 1, 0, 0, 1, 0, 0, 1, 1 form a basis of R cube. Now we need to check whether these three vectors form a basis. That is, they must be linearly independent and they must span the vector space R cube. But the dimension of R cube is 3 and the number of elements given are also equal to 3. Therefore, let us put those three vectors in the form of a set S. Cardinality of S is equal to 3 and which is equal to the dimension of the vector space R cube. Therefore, by the result, one of the above result, S is linearly independent and hence form a basis of R cube. Next, let us check whether it is linearly independent. So to check whether it is linearly independent, so let us take the determinant consisting of the given three vectors, that is 1, 1, 0, 0, 1, 0 and 0, 1, 1. When we evaluate this determinant, we get the value equal to 1, which is not equal to 0. Therefore, it is linearly independent. Since it is linearly independent and the number of vectors is equal to the dimension of the vector space, they form a basis of the vector space R cube. Now let us check using the Maxima code here. The Maxima code runs like this. The first line is kilol. We know the kilol command, that is kilol command deletes all the user variables, functions, arrays and brings all the functions to their default states. Now let us represent the given three vectors in the form of a matrix. Let us use the user variable A colon matrix, the command to display the matrix, and the rows are written within the square brackets. Next, to find the determinant of this matrix A, we use the command determinant of A, which returns the determinant value of matrix A. And let us denote that by D. If D is equal to 0, that is the determinant value equal to 0, then the given vectors are linearly dependent and hence they do not form a basis. Else, if D is not equal to 0, the given vectors are linearly independent and hence form a basis. Now let us execute this Maxima code in the Maxima window and check whether it gives us the result. So this is the code to check whether the set of vectors are spanning or linearly independent and hence form a basis. Let us use the keys Shift Enter. So now we get the output as the matrix A here and the determinant value is equal to 1 and the output is the given vectors are linearly independent and hence form a basis. Now let us check one more problem, a little different one. Here we need to show that the given vectors are not a basis of RQ, and we need to determine the dimension and the basis of the subspace spanned by the given vectors. To check whether it is not a basis, it is enough if we check whether they are not linearly independent vectors. So for that, let us take the matrix A and find the determinant value. So the determinant value is 0. Therefore, the set of vectors are linearly dependent and hence they do not form the basis of RQ. Now let us take this matrix A, bring it to the row reduced echelon form, and the number of non-zero rows will give us the rank of the matrix, and that is the dimension of the subspace. And the number of non-zero rows will form the basis of the subspace. So here when we bring it to the row reduced echelon form, here there are two non-zero rows. Therefore, rank of A is equal to 2. And hence the dimension of the subspace is also equal to 2. And the basis of the subspace is given by the two non-zero rows here, that is 1, 2, 3, the first row vector, and 0, 1, 9 by 5, the second row vector. These two non-zero rows will form the basis of the subspace. Hence we have found the dimension of the subspace and the basis of the subspace. Now let us check with the Maxima code here. So the Maxima code runs like this: kill all. We input the matrix, we find the determinant value. If the determinant value is 0, the vectors are linearly dependent and hence they do not form the basis. If determinant is not equal to 0, that is D is not equal to 0, the given vectors are linearly independent and hence they form a basis. Next we need to find the rank and the dimension of the subspace. So to find the rank of the matrix, the command is rank command, which returns the rank of the matrix, so rank of A, and we represent that by small r. So let us give the print command here. So dimension of the subspace is equal to R. Next, to find the echelon form, we have the echelon command which returns the echelon form of the matrix A. And the subspace will be generated by the non-zero rows in the echelon form. So how many non-zero rows will be there? The number of non-zero rows will be equal to the rank of the matrix. So to extract the non-zero rows, let us use the loop here, that is the for loop, for I running from 1 through R. So where R stands for the rank of the matrix, we dist the non-zero rows, giving the dist command E of I. For I is equal to 1, we get the first non-zero row. For I is equal to 2, we get the second non-zero row. Likewise, for I is equal to R, we get the rth non-zero row. So now let us check whether this command, that is a Maxima code, gives the output required. Let us copy this command, put it in the Maxima window. So let us paste it in the Maxima window. So it runs like this. So let us use Shift Enter keys to obtain the output. So this is the given matrix and the determinant value was 0. Therefore, the given vectors were linearly dependent and hence they do not form the basis. Dimension of the subspace which we got was 2, that is the rank was 2. And the subspace was generated by the two non-zero vectors, that is 1, 1 by 3, 0 and 0, 1, 9 by 5. Here the non-zero rows are extracted from the echelon form of the matrix. So here the output will definitely differ from the manual part. Here within the system, it may interchange the rows and it will bring it to the row reduced echelon form. So the output non-zero rows will be different from the manual part. So sometimes it will be similar, sometimes it will be different. Here we have obtained a different one. Only one vector is equal to the manual part, the other one will be different. Anyhow, these two will form the basis of the subspace. And when we take the equivalent matrix here, so that will give you the basis of the subspace. Now, the other way of asking the question is, find the basis and dimension of the subspace spanned by the vectors. Here they haven't asked us whether they are forming the basis or not. Here, as soon as you see the number of vectors here, there are 4 vectors here and they belong to R cube, and the dimension of R cube is 3. Therefore, the number of vectors are more than the dimension of R cube. Therefore, they definitely become linearly dependent. Hence, they do not form the basis. Now, let us find the basis and dimension of the subspace. So, take these 4 vectors given and put it in the form of a matrix, each vector in each row. Bring it to the row reduced echelon form using the row operations. So when we bring it to the row reduced echelon form, we obtain the final format in this form. How many non-zero rows are there? There are 3 non-zero rows. Therefore, rank of the matrix is equal to 3. Since rank is equal to 3, dimension of the subspace is equal to 3. And the basis of the subspace is determined by the 3 non-zero rows here. The 3 non-zero rows are 1, 1, 1, 0, 1, 2 by 3 and 0, 0, 1. So these 3 vectors will form the basis of the subspace, and this subspace has the dimension is equal to 3. So in the previous problem, whatever we used, the same thing we are going to use as the command here. But in place of the vectors given, we need to paste these 4 vectors. So let us take these 4 vectors, go to the Maxima window, and within the matrix, let us paste these 4 vectors within the ordinary brackets. The vectors need to be put in the square brackets. Each row will be represented within the square bracket. So put it in the square brackets here. So this will be the representation of the vectors within the square brackets, and they form the matrix A. Now we need to check whether these are the basis of R cube. So it is not a basis. So let us delete all those codes here. We need to find only the dimension of the subspace and the space generated by the vectors. So let us have the matrix command. Let us have the determinant command. Even determinant command is not required here because we are not using D here. So it is enough if you find the rank. Let us give the print command, that is the dimension of the subspace is R. Echelon, we need to find the non-zero rows here. So let us give the disk command for the subspace generated by the vectors. And here we are using the loop for finding the non-zero rows or extracting the non-zero rows from the echelon form. So now let us execute using Shift Enter key. So we get this is the input matrix here, and the dimension of the subspace is 3. That is what we got in the manual part, and the subspace is generated by these 3 vectors, that is 1, 0, 1 by 3, 0, 1, minus 1 by 9, and 0, 0, 1. So now this will be the required result. And here we got the dimension of the subspace is 3 and the space was generated by these 3 vectors. Similarly, we can solve the fourth problem, that is finding the dimension and the basis of the subspace generated by these 4 vectors. All the 4 vectors belong to the vector space of all 2 cross 2 matrices over R. So while using the Maxima command for such problems, put each vector, that is the 2 cross 2 matrix, in a quadruple and then execute using the same command which we have used in the previous examples. Hope everybody followed how to find the basis and the dimension of the subspace, and whether to check the given set of vectors are linearly independent or linearly dependent, and hence they form a basis or hence they do not form a basis. Thank you.